All right, guys, now it's time to actually prove some identities. So the difference from just simplifying them is we got what looks like an equal sign. Okay, don't get confused. This is not an equal sign. It looks like one, though. So whenever you're doing proofs, make sure you're looking at all these. These are your trigonometric identities. These are what you're going to use to attack your proof. Let's look at the first. Tangent theta over secant theta. We need to prove that that's equal to sine of theta. This is not an equal sign. It's a possible equal sign. So we can't, add to both sides, subtract from both sides, because we don't know it's an equal sign yet. We're trying to prove that it is an equal sign. You can mess with one side and one side only. So what we decide on is which side looks more complicated. The left side in this case looks more complicated, so that's where we're going to start. Now in the middle of the proof, sometimes we might have to switch sides, but we're going to stop working on one side and then work on the other side. We never work on both sides at the same time. So we can work on one side or we can work on the other side, but we can never mix. That's not a real equal sign. Okay. Not until we prove it is. So again, we pick the more complicated side. After that, we try and write everything in terms of sine and cosine if it's not already. We got a tangent and a secant. Tangent, sine over cosine. Secant, 1 over cosine. Let's see what happens. These do get long. So make sure you give yourself plenty of space to work. So secant is 1 over cosine. And if we look at it, we have a fraction divided by a fraction. 5th grade math again. And this is equal to sine of theta. That's what we're trying to prove. Don't mess with it. Just keep writing it down every step of the way. Now I'm going to rewrite it. Sine of theta over cosine of theta times cosine of theta over 1. When we divide by a fraction, we multiply by its reciprocal. Okay. Again, we're going to cancel these cosines out, but I'm not going to mark it in my proof. If we need to do scratch work, we can do it on the side. In the proof, we just have our statements. That's equal to sine of theta, supposedly. On the next step, if we do cross out these cosine of theta, we'll be left with sine times 1 over 1 over 1. So it's just sine, right? So we get sine of theta on the left. That's equal to sine of theta. Hey, we got what we're trying to prove. We are done now. To signify the end of your proof, you can do one of two things. I like this little square box right here. Fill it in. That's probably the easier thing to do. Or you can put QED, quadratic demonstratum. Signifies the end of the proof. Either way you want to do it is fine. I'm going to use this little square period thing. All right. There's a lot of these. I don't think I'm going to do all of them. We'll see what happens. So which side looks more complicated to you? Left side. It's got more stuff on it, right? So I'm looking over here. I see secant squared theta. And I see a secant squared theta here. So maybe at the end, I'm going to need to rewrite it. But for now, what I'm going to do is put everything in terms of sine and cosine. At the end, it needs to be secant. But for now, when I'm working with it, sine and cosine. Again, secant is 1 over cosine. So secant squared is going to be 1 over cosine squared. Now this is times sine of theta, or sine squared of theta. But again, we're messing with fractions. Make sure it's fractions, plural. Make them all fractions. If it's not, put it over 1. Every step of the way, you need to have both sides of your equation. Now, how do we multiply fractions? Numerator to numerator, denominator to denominator. That's sine squared theta over cosine squared theta equals secant squared theta. From here, we can rewrite this. Sine over cosine. That sounds familiar. It should. It's what tangent is. This is 1 plus tangent squared theta. All right, equals secant squared theta. I see a square in here. I got nothing else to add, subtract, or divide, so let me look at my Pythagorean identities. This one has tangent squared. Tangent squared plus 1 is secant. Oh, hey, that's what we need. There's the identity I'm using. I'm going to put this off to the side as scratch work. I'm not going to put it inside of my proof. So I'm going to use this, and oh wait, I can see it directly. I'm going to erase this in a moment. This right here is the same as this right here. That's just, commutative property of addition. So I can just literally rewrite 1 plus tangent squared of theta as secant squared theta. I have an identity for that. I don't do any work inside of my proof. I don't have to rearrange this thing because it's already what I need it to be. I just wanted to see what tangent squared was, and hey, look at that. That's exactly what I want. So I can rewrite this as secant squared theta. On the right side, I have secant squared theta. They match. We are done. Quadratic demonstratum in the proof, whatever you want to do. So those first two weren't too bad. They do get a little longer. If we look at this one, I'm not going to start with the left side. That's only one little function. I'm going to start with the right side because that looks more complicated. So I'm going to write down my left side, not changing it. Cosecant of theta is equal to. Let me rewrite my right side in terms of sine and cosine. Cotangent is cosine over sine. Sine theta over sine of theta. And then we have secant is 1 over cosine over, big fraction bar there, 1 over cosine theta plus sine of theta. We can subtract sine of theta from both sides, right? Wrong. You cannot treat this equal sign like a regular old equal sign. You can't multiply by anything, both sides, none of that. You're just simplifying the more complicated looking expression. Like this one's not even there because we're trying to make it be this. This is our goal. This is what we want it to look like. But we can't use the fact, because it's not a fact yet, that it is. We're trying to prove this fact. Okay, so let's just see. Wow, that was not what I wanted to write. Cosecant of theta, not theta. I'm dividing by a fraction. I multiply by the reciprocal. See a pattern here? Lots of basic arithmetic and lots of basic algebra shoved together, and that's what makes these things long and tedious. Difficult? Not so much. Tedious and long? Definitely. I didn't mess with the sine of theta, so I'm just going to write that down. All right, so let me multiply this here real quick, not changing my left side. Cosine times cosine of cosine squared over, sine of theta. Sine of theta times 1 is just sine of theta plus sine of theta. Again, I'm dealing with fractions, so make sure it's fractions, plural. All right, I'm adding 2 fractions. I need a common denominator. You can do this however you want to do it. Yes, the little butterfly trick will work. I'll show it to you and then I'll erase the marks in my proof. So this times this times this, and then these 2 times each other. That's the butterfly, right? Or you could just think about it. I'm going to put it in red so I can erase it in a minute. I need to multiply by a common denominator. This denominator is sine of theta, this denominator is 1. So I need to multiply sine of theta to the numerator and denominator. Because sine of theta divided by sine of theta is 1. I'm not changing the value, just how it looks. Either way you want to do it's fine. I don't want to see the work in the proof. If you need to do scratch work, do it on the side. So if you need to do this, work this out, do it off to the side, do it on another sheet of paper. I don't care, but do not do it in your proof. I'm going to use a butterfly because I can do it in my head. It's not, oh, wrong. It will work for these most of the time. So 1 times cosine squared theta is cosine squared theta. Sine of theta times sine of theta is sine squared theta. This symbol goes between them. Yes, the order matters. We do this first and then this. Over sine of theta times 1 is sine of theta. And if you simplified enough equations, you should recognize something lovely right now. Pythagorean identity right here. I'm going to use it, but again, this is not going inside of my proof. This is off to the side, scratch work. I have a whole big old column of scratch work if I need it. Not inside my proof. So right here, cosine squared plus sine squared, well, that's just simply equal to 1. So cosecant of theta is equal to 1 over sine of theta. Oh yes, yes it is, isn't it? That's one of my reciprocal identities. Cosecant of theta is 1 over sine of theta. So now I can write cosecant of theta is equal to reciprocal identity cosecant of theta. Done. All right. So let's keep going. I'll go kind of fastish. Try and get through most of them, if not all of them. Some of them do tend to take a while, so might not get through all of them. I'm definitely going to start on the right side here because it's just sine of theta, and that's so much complicated than this. Yeah, no. Whatever's more complicated, that's more complicated. Start there. Right in terms of sine and cosine. Look at your trig identity sheet. Cosecant is 1 over sine of theta. Cotangent is cosine of theta over sine of theta times cosine of theta. I'm going to put that over 1 because it's a fraction here. I need a fraction there. Equals sine of theta. Don't mess with that dude. Leave him alone. Okay, nothing I can really see here. Let me just go ahead and multiply this. Let's see what happens. And remember, these are just numbers we're manipulating, just some unknown numbers. So all the rules like multiplying and adding fractions work the same. Cosine times cosine is cosine squared over sine of theta. Hey, look, these have a common denominator already. That makes it lovely easily to add. So that's going to be 1 minus cosine squared theta over sine of theta. They have a like denominator. We just add the numerators together. Well, subtract them, you know, because it's a minus sign, but subtraction is just negative addition. Not a real thing. Sine of theta, that's not changing. Don't touch it. Leave it alone. Again, you should recognize, yeah, you can see the point of the screen. You should recognize this if you've been dealing with these a while. That's right. We're using that Pythagorean identity again. This one right here. So this time I am going to do some scratch work off to the side, not in my proof. My proof stays clean, free of scratches and work and all that mess. Nice, clean proofs. So I need to get 1 minus cosine squared theta. So I'm going to subtract cosine squared theta. Or you could have solved for cosine squared theta and then plugged it in. Either way you want to do it. Again, there's trillions of ways to solve these things, not literally, but there are quite a few. So sine squared theta equals 1 minus cosine squared theta. Oh, hey, 1 minus cosine squared theta is equal to sine squared of theta. Let's use that. I'm using an identity, so I can just simply substitute there. And yeah, if we have something squared divided by just one of those things, you subtract the powers, right? Same concept as x squared over x. You don't need to do this at all, but just to think about it, how do we divide with powers? We subtract. 2 minus 1 is 1. So this is just going to be sine of theta equals sine of theta. Hey, looky there, we're done. Keep going. Number 5. This one looks terrible. Might be, might not be, I don't know. Look to me deceiving. The simplest one could take like 2 pages. The most complicated looking ones might take 3 steps. We don't know. Just start doing it and find out what happens. Pretty sure it's going to take a minute. So cosine squared theta is going to stay cosine squared theta. I'm not messing with it. These I'm going to turn into sine and cosine. So cosecant, if you don't know, is 1 over sine. If you don't know, look on your trig identity sheet. Multiply that by cosine of theta. It's not a fraction, make it b1. b1, b so, b1, whatever. Tangent theta, sine theta over cosine theta. Hopefully you do this enough to realize that tangent is sine over cosine. Times cotangent. Well, hey, cotangent, that's a, whew. Make sure you don't turn plus signs into multiplication signs, because that's completely and totally different and won't work. That's plus, not times. Whew. Cotangent is cosine over sine. All right, so if you need to, here's tangent, here's cotangent, here's cosecant. Not messing with the left side. Can't take the square root of both sides. No, you can't mess with both sides. Don't do it. Not an equal sign. It's a pretend equal sign. Top part's easy enough. So cosine theta over sine of theta. Okay. Again, there's many ways to go about doing these. I'm going with the most straightforward way, not the shortest way, not the most elegant ways, but the ones that make the most sense. Because, I mean, right here, you might recognize that as cotangent, and then you could actually divide everything by cotangent and do some weird stuff and it'll work. Just if you see it, great. If you don't see it, then don't worry about it. I got 2 fractions to add. Butterfly. Sine times sine is sine squared. Sine times cosine is cosine squared. Don't forget your symbol between them. Yes, the order matters significantly. This times this, then this times that, with a sign in between it. Plus signs doesn't really make a difference, but minus signs makes a huge difference. We're going to put that over this times this. Cosine theta, sine theta. All right. So let's see what's, hey, I got some squares up in here. Hey, we like that. Cosine squared plus sine squared is 1. I'm going to rewrite this as 1 because it is. Leaving the left side alone. Cosine theta over sine of theta over 1 over cosine theta sine of theta. How do we divide by a fraction? Flip it and multiply. Cosine. 1 second, please. All right, I'm back. Sorry about that. So not changing the left side. We got a fraction over a fraction. Flip the second one and multiply. You know what to do. Cosine theta, sine of theta, over 1. Remember, it's easier to simplify before you multiply, always. So I'm dividing my sine of theta here and multiplying right there. Imaginary, cross it out in your head. It's gone. Do not cross it out in your proof. I will take points off. So sines cancel. Relative cosine times cosine is cosine squared theta. And there's a bunch of 1s, so that's it. We're done. Proven. Beautiful. All right. Let's see what the next one's got for us. Actually, I'm going to go back and do this one the other way because it's going to be like really short. Just for funsies, to show you that there's a slew of ways to do these things. If you don't want to think about these and just don't have a method for it, skip what I'm about to do and go to the next problem. Skip. Okay. So if you do want to look at the fun way to do this, it's actually really interesting. So if I'm looking at this, if I'm fluent with my trig identities, right? You're going to get fluent because you're going to do these things so many dang times. You're going to get tired of them. I recognize cosecant as sine, right? I see this as cosine over sine. I know that's cotangent. So I'm going to rewrite just the top part. I'm not going to mess with the bottom part. Watch what happens. If you're not wanting to look for a fun short way to do it, skip it, because this requires out-of-the-box thinking. You might just go methodically, to put it in terms of sine and cosine, do some arithmetic, and be happy with everything. I recognize this as cotangent of theta. Cosine divided by sine is indeed cotangent of theta. So yeah, if you're here, then you should know your trig identities decently well. Now you know if you multiply the top and the bottom of a fraction by the same number, you don't change the value of the fraction, right? Well, remember, dividing is the same thing as multiplying. Division is just a multiplication of a reciprocal. So what I'm going to do is, again, this is going to go in red, so I don't actually do the work. I'll show you the work on the side. So I'm going to take this and do some scratch work. So I'm going to multiply the numerator and denominator by 1 over cotangent of theta. And if I do that, this numerator is going to be a 1. I distribute that, that's going to be tangent of theta over cotangent of theta plus 1. So now we got a bunch of 1s. It's a lot easier to work with. You're still gonna have to do similar steps, but there was ones instead of sines and cosines. So, so I'm gonna write that step out. Maybe shorter, may not be, I don't know, but it's a different approach that you can use. So if these are so easy, they're boring for you, well, switch up a little bit, try something interesting. I'm going to continue working over here. So from there, I got a fraction. Let's combine them. That's over 1. So butterfly it. Okay. So that's tangent theta, that's cotangent theta. That's actually going to be about the same hour. Oh, I thought it was going to be shorter. It's different. What if instead, yeah, we can make it shorter if we, instead of trying to do that, we put it in terms of sine and cosine now. Aha. So that's 1 over, it's going to look weird, but it's sine of theta over cosine of theta. Yeah, I definitely want to skip this unless you're really good at these. And you really just want to have fun with it. Tangent is sine over cosine. Cotangent is cosine over sine. How do we divide? Yeah, we got a fraction and a fraction and a fraction. It happens. Okay, I'm going to write that out. I should just not done this, but whatever. You can skip it. All right, how do we divide by a fraction? We flip it and multiply. So I'm just going to do some scratch work for my scratch work. Times, flip it, that's sine of theta over cosine theta, right? This is going to be 1 over sine squared theta over cosine squared theta plus 1. As you saw, there's a whole other route I could have taken a minute ago, but this way is a little bit easier than that other route I was going to do, and more fun. Now we can butterfly, that's 1 over 1. 1 over sine squared theta plus cosine squared theta. Yeah, that's right. We got ourselves Pythagorean identity going on. Hey, not my face. Over cosine squared theta. Oops. We need to write this step. We didn't write that yet. Yes, I'm doing this same thing twice because any scratch work I need to do over here. I guess I could, on this part, I could have written it over here because I didn't do it, but whatever. Scratch work does not go inside the proof. So Now I don't need to do any scratch work because I know that's a 1. 1 over 1 over cosine squared theta. Then dividing a fraction. Well, that's not a fraction. Yeah, let's make it a fraction. 1 over 1. 1 over 1 times cosine squared theta over 1. And yeah, that's facing the way again. Definitely more work this way, I guess. But it was fun. Hey. Now we have cosine squared theta equals cosine squared theta. Good thing to learn from this is there's tons of ways to do this that are not wrong. Some are easier than others. Some involve different tricks than others. Just do it however you see it. But yeah, I would definitely suggest going this route. I think it was shorter. Yeah, that was a little shorter. So let's just go that way. And it's more straightforward. Put it in terms of sine and cosine and be done with it. Anything. Okay, so hopefully you skip that part of the video unless you're really bored. Next problem. Yeah, okay, definitely 1's the most complicated part here, so I'm gonna mess with 1. Kidding. I could just go ahead and butterfly that, or think I'm gonna put it in terms of sine and cosine first. Let's see what happens there. Secant, 1 over cosine. I'm dealing with fractions, so better go ahead and put this as a fraction. Tangent, sine over cosine. Cotangent, cosine over sine. Equals 1. So here we go. Fraction over fraction, fraction over fraction. You know what to do. 1 over cosine theta times 1 over cosine theta multiplied by the reciprocal minus sine of theta over cosine of theta times the reciprocal sine of theta over cosine theta. Cosine times cosine, that's cosine squared, so it's 1 over cosine squared minus sine squared over cosine squared. Oops, I forgot my equals 1. Don't forget equals 1. Now, here's some times when it's definitely better to not mess with cosines and sines, because look at what we're trying to prove. We're trying to prove 1, right? How do we prove 1? We got some options. Manipulating cosine squared plus sine squared to give us 1. Tangent squared plus 1 is secant squared, so I could rearrange that. Cotangent, I have to rearrange that. Look at what we're having going on right here. It's 1 over cosine squared. That's secant squared, right? Cosine's 1 over secant, so 1 over cosine squared is secant squared. And then we have sine over cosine. Sine over cosine, that's tangent. I'm dealing with secant squared and tangent squared. All right, that right there, that's my Pythagorean identity. Let's write in terms of secant and tangent. So secant squared theta minus tangent squared theta equals 1. And actually, based on the identity here, we are done. You can do a little scratch work to make sure for yourself. But yes, this is done. And you do want to check it because you might have screwed up a sign or something. So definitely check it. Subtract tangent squared from both sides. I get 1 equals secant squared theta minus tangent squared theta. So I get 1 equals 1. Another way you could have done it, but I'm not going to because I've already wasted way too much time. Butterfly it. Oh wait, it's already like terms. So we have 1 minus sine squared theta over cosine squared theta. Use this identity. Sine squared theta is equal to 1 minus cosine squared theta. Oh, cosine squared theta is 1 minus sine squared theta. So we'd have cosine squared over cosine squared, which cancels out to 1. Same thing. Either way you want to do it is fine. It will work. But this way it involves not dealing with adding fractions. So that's the way I chose. If you don't see it, it'll still work. It'll still work. There's a plethora of ways you can do these things. Keep going. How many more do I have to go? Okay, there's a dozen of them. And we're halfway through. No idea how long this video is going to be. Okay, let's just move it. I got something on the left side. I got something on the right side, and they both look pretty nasty. What if I just add 2 sine squared theta to both sides and see what happens? This is not a real equal sign. No adding across the equal sign. No multiplying. No, none of that. You messed with one side only. If they both look terrible, eeny, meeny, miny, mo. I don't care. Doesn't matter. Just pick one and mess with that one. If you get stuck on the one side, pick the other side from where you're at and work with that one. When they finally match, you're done. Really, there's nothing for me here. I'm just going to go ahead and pick the left side to mess with. So I'm going to write down my right side as soon as I figure out what to do with this left side. My right side has just sine squared theta in it, all right? My left side has cosine and sine, so I guess that is kind of more complicated. Only way I know how to mess with those is with the Pythagorean identity for now. Not that Pythagorean identity. The other. I'll get it right the third time. Third time's a charm, right? There we go. So what can I do? I want to get rid of this cosine squared because this thing's only got sine squared. So let's see what happens if I solve for cosine theta. Cosine squared theta is equal to 1 minus sine squared theta. Okay, substitute it. 1 minus sine squared theta minus sine squared theta equals 1 minus 2 sine. Wow. It's like that, y'all. Combine your like terms and you're done. Negative sine squared theta minus sine squared theta is negative 2 sine squared theta. It looked terrible, but look how short that was. That was nothing. That was a baby proof. Easy peasy. You can squeeze the limits if you want. Next. Now let's just go for it. This thing's got multiple different trig functions. I've only got one solitary thing, so that's the left side. Sine and cosine, let's do it. 1 over cosine squared theta times cosine squared, wow, that's easy. Cosine squared theta over sine squared theta minus 1 equals cotangent squared theta. That's cotangent. Make sure you don't magically change cotangents to cosines or vice versa, because that will definitely screw you up. Canceling. Not in your proof where I take off points. But they do cancel, so I'm left with 1 over sine squared theta minus 1 equals cotangent squared theta. So I write my t's in different ways. Deal with it. Oh, hey, 1 over sine squared, that's cosecant squared theta. Minus 1 equals cotangent squared theta. Yes, yes, it does. I know that. Why do I know that? Because, well, we had slightly rearranged. So let's manipulate this. Pythagorean identity right here. Again, we're going to do some scratch work just to show ourselves that we're not going crazy. We're already there. Subtract 1 from both sides. Cotangent squared theta is cosecant squared theta minus 1. Okay, that's cotangent squared theta. Let's put some EV proofs in the middle. That was fun. Let's see what's next. Definitely gonna mess with the right side. I definitely recognize that as Pythagorean identity right there. Isn't that the same one we just did? Yep. So I'm just gonna go ahead and copy paste that. We're gonna need that. So when you see squares, you might want to think about Pythagorean identities first. It may or may not be easier. I don't know. May or may not be easier. I'm gonna just go with it right now. Let's see what happens. Especially if it's like this with a minus 1, that's probably going to be easier because that's probably going to turn into one thing. We don't have to add fractions. Let's see what happens. Said that like 20 times. Sorry. Secant theta is equal to, rearrange this. I just did this. It's so familiar. Don't go crazy while you're proving things like this. You're not doing it right. So yeah, that's cotangent squared theta. Cosecant squared theta over cotangent squared theta. Now, here I'm going to go ahead and write in terms of sine cosine. But yeah, if I have a Pythagorean identity, I can just go ahead and do that first, so it's less fractioniness, I guess. Now I mess with your left side. Cosecant is 1 over sine. Look at your identities until you know them by heart. Cotangent is cosine over sine. It's squared. See how this one's going? We got a fraction over a fraction, so guess what? We multiply by the reciprocal. You know the drill. Cancel out stuff in your proof, or I'll take off points, or just fail you instantly. My choice. Sine squareds do cancel, so it's going to be left with 1 over cosine squared theta. Sure enough, that's our basic reciprocal identity. Theta is equal to secant squared theta. You must have this last step or you're not right. And by not right, I mean you're wrong. You lose points. You must finish the proof. Yes, you must put this, or QED, whatever you choose, but put something to signify the end of your proof. Okay, I'm not right. Going on. Oh my God, we got some parentheses. Probably that one looks more complicated to me. It's got some parentheses in it. Write the left side down. Let's mess with the right side. See what the heck happens. So what do parentheses mean? Oh, it's distributive property. Yeah, distributive property. Come on. So I'm going to go ahead and just distribute the dang thing. You could write that in terms of sine and cosine first or second. Doesn't matter. I'm going to go second. Cosecant theta times cosine of theta is cosecant of theta times cosine of theta plus cosecant of theta times sine of theta is cosecant of theta times sine of theta. Now, I'm going to write in terms of sine and cosine. Not messing with you left side. Left side stays alone. Cosecant, that's 1 over sine of theta. Cosine of theta. Messing with the fraction, make it fractions. Cosecant is again 1 over sine of theta. Oh wow, this one's easy. Sine of theta. Make it a freaking fraction. Cotangent of theta plus 1 is equal to cosine over sine. I'd let you skip this step. I'm gonna write it out, but multiply the fractions. I think I could get by with you not putting this step. I could let this step slide. They cancel. Don't do it in your proof. All right, we'll take off points regardless. Yeah, just don't do it. Don't cancel your proof. So finally, we do have this nice quotient identity here. Might help if I write the whole side down. And we're done. Okay, not too terrible. Let's see. Definitely starting with the left side. That's cosine, that's sine, that's tangent. Going to put that in terms of sine and cosine. Tangent sine over cosine. Now remember, look at your identities. Yes, I'm talking really fast for no apparent reason. Whatever. Cosine of theta plus sine of theta times sine over cosine. I'm messing with the fractions, so make it fractions. Probably gonna do this in a minute, but not right now. Cosine of theta plus sine squared of theta. Okay, I see what we can do. Over cosine of theta. One. I see something else we could do that would be easier. Cool. Equals secant of theta. So my first thought was, well, I can rewrite sine squared in terms of sine and cosine, but that wouldn't have done too much to help us because it would have just made it more complicated. Then I was like, well, we could just add the two fractions together. And hey, yeah, if I do that, that's going to be a cosine squared, so that's going to make it really easy. And that's what we're going to do. So butterfly it. Cosine of theta times cosine of theta is cosine squared theta. The order you butterfly matters. Plus sine squared theta. I can't believe I'm using the butterfly method, but hey, it works. And if you're here in algebra 3/2/whatever the heck you are, I guess you can do some of the tricks. But do not say that F word. That does not work. Called distributive property. Do you see it? Sure, by now you can see it. You see it, right? I see it. You see it? You see it? You see it. That's a 1 over cosine of theta. Parents are nodding their head. Yeah, we saw that a long time ago. You're just so slow. Good thing about teaching your clothes, you don't have them barking or making car noises in your classroom. So let's go a little faster. All right, last one. Can't believe we're doing them all. Oh my God, that is terrible. Might not be. It looks terrible, but it might not be. Really, that's nasty. Left side looks more complicated because it's got a fraction. Yeah, it's got a fraction. Let's just do something. So I got sine and cosine on the bottom. Let's put it all in terms of sine and cosine. See what happens. Cotangent. That's cosine over sine. If you don't know that, use your identity sheet. If you do know that, good. Tangent is sine over cosine. See what's going to happen next, right? You can't see what's going to happen next yet. You haven't been doing these enough. Do some more. My bottom is sine of theta times cosine of theta. I'll leave it like that for now. But in the next step, I'm going to make that a freaking fraction because we're going to divide by a fraction. All right, hang on. I got to go back and check something. Okay, I thought I'd have to find secret theta on all this stuff. Okay, back. Write down your other side. Don't touch it. Don't change anything. Don't even breathe on it. Just copy it down as is. Do not mess with two sides at once. No. Pick one side, manipulate it, simplify it, whatever, till it looks like the other side. If you get stuck on one side, then you can go try and manipulate the other side from where you're at, but not at the same time. Never, ever, ever at the same time. Back to this one. Subtracting fractions, butterfly, make freaking sure you do it in the right order. If you don't know the butterfly, that's fine. You just get a common denominator. This needs a cosine, this needs a sine. Times sine over sine, times cosine over cosine. You see what happens. If you need to do scratch work, do it over here. I don't need to do scratch work. I can see what's going to happen. I'm going to use the butterfly method. I know what's going to happen. Cosine times cosine, cosine squared. This symbol, and here's why the order matters. That's a minus sign. Sine times sine is sine squared. Oh, that's super easy. That's, wow, so easy. Over sine of theta times cosine of theta. Over big division bar for right here. Sine of theta, cosine of theta. I'm dealing with freaking fractions, so make it a freaking fraction. Root over 1. That's equal to this stuff over here, not messing with you. Just chill. Joe, what you want to do over there? Just leave us alone. We're leaving you alone. You see something nice, don't you? I hope you see it. 1 Pythagorean identity over sine of theta, cosine of theta, over, did I write that down? Yeah, okay. Theta cosine of theta over 1. This might be one where I have to manipulate the other side in a minute. At this very moment, I'm going to be honest with you, I'm not seeing how it's going to work out. So in a minute, I might have to manipulate this right side. I'll keep working with this side till I can't do anything else. But I'm thinking I'm going to get stuck in a second. Also thinking it's a good thing I have a little arrow down button that I can get as much space as I need. These things take some paper. Dividing by a fraction, so I'm going to invert and multiply, reciprocate and multiply, flip it and multiply, multiply by the reciprocal, whatever the heck you want to call it. Yeah, so I didn't mess up, I don't think. So it's possible I messed up also, but for right now, I'm just gonna go with it. If I messed up, my bad, sorry. I'll probably just leave it in the video anyway. It's good to see errors. So that way you don't screw up how I screw up. If I screwed up, I don't know. Sine squared theta, cosine squared theta. That's a that's a cosine? Sorry, that looks like an N. So cosine squared theta. How am I? It's late, guys. Sorry, I'm just dropping letters left and right. I don't see anything else I can do with that left side. I mean, sure, that's the same as that's cosecant squared times secant squared, but minus? How am I going to turn that into minus? I don't know. I'm stuck on the left side. I don't know what to do on the left side. So I'm going to go to the right side. So now I'm not touching the left side. The left side is not being touched. It's going to go drink its own cup of coffee. It's on coffee break. So copy down the left side. So just in case. Scrolling through here, fast forwarding the video, you're not listening to my words. I switch the sides because you can definitely read my handwriting's awesome. And yes, this is my normal handwriting, not because I'm on a computer, if you're wondering. See, look, I think I do it a little bit better on the computer. So I'm not touching the left side. I'm switching to the right side. Coffee breaks over right side. Let's see what I can do with you. Okay, so, well, put in terms of sine and cosine, why not? 1 over sine squared theta. Oh yeah, it's gonna work. Minus 1 over cosine squared theta. I see. See, could I have done some stuff to make this happen? Sure, but I didn't see it. I got stuck. So I'm gonna switch to the other side and see what happens. And I did one step and it's like, that's obvious. It's obvious, isn't it? It is. Butterfly the dang thing. Cosine squared theta minus sine squared theta. Okay, that's a little different than I was expecting. I might have to go look at the answer. I don't know, because this just changed. I thought something was happening, but it didn't. That would have been plus, I'd be done, but it's not a plus, is it? It's a minus. There's no way that's true. Let's just keep going. Because we now have, we did this times this times this, and that's going to be sine squared theta cosine squared theta. If this was a plus sign, if that was a plus sign, then that would be a 1. Then we'd be done. So something's wrong either in my work or in this problem. I don't know. I'm going to pause the video, go look at the answer key, and see if I can figure out what I did wrong or if it's a typo or what. And then I'll go laugh at myself for being wrong. Pausing the video, be right back. Ha 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 ha. Yes, I see where I messed up. I messed up. I got overzealous. I put a 1 right here. Oh, look, it's a minus. So that means everything below this point is wrong because I didn't use its actual identity or anything like that. So yeah, that's wrong. So basically, erase all this mess. Sorry if you were writing it down, thinking you're the whole answer or whatever, but yeah, I make mistakes. There it is. Don't make my mistakes. See, that's a minus sign, it's not a plus sign. Don't do that. And I'm just going to go ahead and copy, paste. Break my computer maybe. There it goes. This step is correct. Wow, I messed up actually the second step. So you know, you just crumple up a piece of paper, throw it away, and start the problem all over fresh. But hey, it happens. Happens to me. It's gonna happen to you. It happens, y'all. Let's just do it. So don't get overzealous. Side a little bit. Okay. So my right side's not going to change. I'm probably not going to have to switch sides up now. That's a good thing. I couldn't figure out what to do because I couldn't do anything. So, let's see. We're still divided by fractions, so might as well just flip it and multiply. Cosine squared theta minus sine squared theta over sine theta cosine theta times, flip it, sorry. See, that's what I need to do, this is these. 1 over sine theta cosine theta. Leaving this dude alone. I'm actually probably going to split it up in a second. I mean, that I could see it happening. That makes perfect sense now. Okay, yeah, this is easy. Like 3 steps to go. Numerator, numerator. That's not changing anything because we're multiplied by 1. Denominator, denominator. We get sine squared theta. So easy now. Cosine squared theta. Go. So we got a fraction here with a subtraction in the middle. We can put them together, or we can break them apart. Let's break them apart. Cosine squared theta over my whole freaking denominator for both of them, because you add common denominators, put the numerators together, and keep the denominator the same. You split them apart, you still keep the denominators the same. I'm adding them together. Yep, cosine's going to cancel here. Sine's going to cancel here. It wasn't terrible, I just screwed up. We fixed it. Our valuable lesson to pay the freaking attention to our signs. If it's a -1, don't, or if it's a minus, don't treat it like a plus. Because that'll completely throw off your problem, as you can see. So imaginary crossing out, imaginary crossing out. Do not do it in your proof so you get points taken off. So 1 over sine squared theta minus 1 over cosine squared theta. This. Yes. 1 over sine is cosecant. And 1 over cosine is secant. I'm just gonna cheat, man. Computer, why not use the tools I've got, you know? Equals that. We did it correctly this time. Haha. And we're done. Well, one mistake on 12 problems. Not too shabby, I guess. All right, guys. So this is the first in a long series of trig identity proofs. We've got more proofs, or more identities to use, manipulate, learn. These are just, oh yeah, see, here's the answer. I was like, what's going on here? And then I saw that minus sign, like, oh. We just have the quotient, reciprocal, and pythagorean identities. When we get back from the break, or you know, I don't know when you watch this video, there's some of the, like, out of the two we need to hear. Next time, we'll be looking at half angle, double angle. Actually, let me scroll down and tell you exactly what. We're going to be looking at some new identities. Sum and difference. Okay, so they're going to do sum and difference next. We'll probably apply them too, yeah. We're going to prove them. We're also going to apply them. That's why we need to make sure every time we stay fresh on evaluating. Double angles, half angles. That should be it, I think, for this class. Let's see if we can add any more. Nope, that's it. Okay. So next time, we're looking at sum and difference. We're going to apply it, and we're going to prove it. Use it to prove things. Then we're looking at double and half angles. Again, applying and proving. And yes, you can have every single freaking identity in one proof. It is what it is. But it is done for now. Goodbye.